Today we are going to switch from heat energy problems to linear expansivity, even though it still has to do with heat energy, but this is a bit different, okay? So we have a question on the board. A metal rod of length 40.00 cm at 20 degrees Celsius is heated, okay, to a temperature of 45 degrees Celsius. If the new length of the rod is 40.05 cm, that means increase the length. Calculate the alpha. Alpha here represents linear expansivity. Let's just switch that with alpha simply means linear expansivity. Okay? And that's what we are asked to calculate. We are asked to calculate linear expansivity of the material. Alright, so what we need to do here is, first of all, we bring out the information contained in the question or the data or parameter contained in the question. So we start by writing down our solution. Right? And then our data here is very simple. The first one, a metal rod of length, so initial length. The initial length of the rod is 40.00 cm. So that means L1, initial length, L1 is equal to 40.00 cm. At 20 degrees Celsius, initial temperature, theta 1. Theta 1 is equal to 20 degrees Celsius. Excuse me. Is heated. So the material is at this point and then heated to a temperature of 45 degrees Celsius. That's theta 2, okay? That is temperature 2. Theta 2 is equal to 45 degrees Celsius, right? Okay, if the new length of the rod, after being heated to this temperature, 45 degrees Celsius, there is an expansion, right? And that expansion gives rise to new length, which is 40.05 cm. So we have L2. L2 is equal to 40.05 cm. Good. Now calculate the linear expansivity of the rod. That's it. Calculate the linear expansivity of the rod. Now we need to remind ourselves there is a connection, the formula for finding the linear expansivity. Right? Formula, we remind ourselves the formula for finding the linear expansivity for alpha is simply alpha is equal to L2, okay? Length 2 minus length 1, okay? All over length 1, alright? And then temperature change, theta 2 minus theta 1. That's it. That's the formula we are going to apply. So if we apply this, it's very simple. All we need to do, we have already defined our data that L1 is that. So we just substitute. Here L2 is 45.05, okay, minus L1 here is 40.005 cm, 40.00 all over. What do we have? L1 again 40.00 bracket open. Theta 2, our theta 2 is 45 degrees, and we have 45 degrees. Then minus theta 1. Theta 1 is 20 degrees, and that is 20 degree bracket close. Alright? The remaining aspects, we can now find out what happens here. Alpha is now, we'll now simplify further. If we simplify further here, 45.05, right? 45.05. Is it 45 or 40? That is 40, not 45. That is, where's my duster? That is 40. Avoid unnecessary mistake here. 40.05. Okay, if we said that, it means that 40.05 minus 40 is going to be 0, 0, 0, 0.05, okay, all over, yes, that's it. 4 minus this is 0, this and this down, okay, and what next? We have 0, 5 and 0 that, okay, so over this we have 40, all right, 0.00, then we can ask ourselves, 45 minus 20, 45 degrees Celsius minus 20 degrees Celsius is just 25. So we have 25 here, 25 degrees Celsius. So what happens? We simplify further. We already have this, okay? That is it. I hope we're not confused here. We can still find more. If we say 40.05 minus 40.00, I just want us to be very, very certain. We bring down 5, bring down 0, bring down points, bring down 0, again, bring down. So this is correct. This is correct. Okay? We have cleared that doubt. Okay? Now, what do we do next? Very simple. We need to calculate. We put the 0.05 all over 40 times this. 40 times 25. Okay, let's just do that. 40 times 25 manually. We have 5 times 0 is 0. 5 times 4 is 20. Okay, 200. 2 times 0 is 0. Okay, and then 2 times 4 is simply 8. Okay, it's simply 8. So if we have this, we can now say this is 0, this is 0, and then what happens here? This is 8 plus 2 is 10. So we have 1,000. Okay, 40 times 5, 25 is 1,000. So that has been ascertained. We can now write 1,000. Good. So the next thing we need to do, you are going to do this to prove to me that you have actually understood this. Okay? And the linear expansivity is measured in per Kelvin. Per Kelvin, that's the unit. Per Kelvin, okay? So find out, do the 0.05 divide by 1,000 according to what we have here. Okay? Whatever it gives you, put it here in the comment section. Let's discuss further from there. Alright? Give me some comments. I need to read your comments. I need to see your likes. And I want to have you subscribe. Alright. Next class.